But maybe there's something. Thinking, yes, this is for us the highest level of our own expression, but is there something else? I don't know. It's very difficult to think beyond thinking. So, all right, we have to see, maybe in the future. One thing also I want to stress is that I have shown you this organism called the human being, which was sitting at the end on the right-hand side. When you look at this evolution of the universe, you must also realize that the human being is not the end of the evolution. Nowadays, many people tell us, stop, don't move anymore. This cannot happen. The universe will continue to evolve. And I think maybe in 1,000 years or in 10,000 years, we will not be the same anymore. I'm sure we will not be the same. What we will be, I don't know. At the end of my lecture, you will see something funny. Maybe. So, matter has evolved under the pressure of what you might call information. So, what is then the basic question you should ask? Now here, I'm a bit provocative for the physicists sitting there, the mathematicians sitting there. Of course, mathematics, physics are extremely important for understanding the universe. But what would be the most fundamental question to ask? Of course, general relativity, Albert Einstein, quantum theory, this is very, very important. But what is the most important? Is how is it possible that Einstein existed? So the most basic thing, before we have mathematicians, we must have a way to get mathematicians. And how can this happen? How does matter become complex? And that is chemistry. Because at some stage, these molecules have to get together, have to assemble, have to organize, have to evolve, and so on and so on. And to generate, eventually, a mathematician. Or a theoretical physicist. So, the answer to that question, we know it. Now you may say, it is very arrogant to say we know the answer to the question. Of course we know it. That's it. It has happened by itself. Now when I tell you that it's self-organization, that the complexity of the universe has occurred by itself, that doesn't tell us how it has happened. But we know that there are laws, there are bricks in the universe, what it's made of. There are laws of how these interact, and from this thing, they contain what is needed to make it more and more complex. It happens that in our universe, at least, that's the way it happens. Then we have to try to understand how this happened, because it's also our origin. How is it possible to generate human beings when you start with a Big Bang at the beginning? It took 13.7 billion years, but it worked. So it looks like self-organization is a cosmic imperative. Now what does that mean? It means just that it must have happened. Of course, that's not a great statement, because it must have happened because it happened. And so, okay, the laws must be there to make it possible. And so the self-organization is part of what the universe is, and this is an imperative. It must happen. And some people say even that life is not an accident, as some claim. Life is almost a necessity. You cannot avoid life in the universe. Just because it is, the laws are there, it can organize. Of course, life could have had other expressions. We could have had 10 arms, 20 legs, whatever, like some animals have. But it happened to go some way. It could have changed to a direction. But this organization is sort of inbred, it's embedded in the structure of our universe. Cosmic self-organization is the one way to... nowadays, the unique theory doesn't exist yet. Our friend physicists haven't provided us with a unique theory. There are two, we still need two approaches, unless we hear something from the string theories that maybe he has solved the problem already. But from the last news I had, it wasn't solved. So we have to consider two types of self-organization. One is the structure, on the big scale, the organization of the universe. And this, the cosmologists tell me, Martin Rees and others, that the universe has become structured by the action of gravitational forces. Right after the Big Bang, there were inhomogeneities in density of matter, and the rate of expansion. And the gravitational forces acting on that created then the stars, the galaxies, and so on. That's not what we are interested in. We as human beings are interested in self-organization through what is called electromagnetic forces. So the bricks, the atoms which make up the universe, they got together, interacted through these electromagnetic forces, and these forces then led to these very complex entities called molecules, and then more and more complicated type of objects. And this was structured by the fact that they can get together, they can, by obeying very strict laws, they can build up big molecules, and of course these molecules could have been different. They could have been different. But it happened that they were what we have now. In other words, the evolution of the universe, I will come back to that, is not something which was straight. It was at a point, and then it had certain possibilities. So if you go one way, you go here, then you go here, but you could have gone this way and go somewhere else. But it happened one way, and once it has happened, it's rational that it happened this way, but there were many diverse possibilities. Now, then this being over there, which eventually was generated here, invented something which is curiosity and trying to understand what we are doing all around. In other words, thinking, Homo sapiens. This is a famous statue by Rodin, as many of you know. It's probably one of the most famous statues produced in France, I would say. And so, produce science, which is the way for understanding the universe and how it is nowadays, how it evolved, how it formed, and maybe, if we understand enough of it, maybe even predicting some of the things which may happen in the future. So, now, science, I indicated, is of course very important for future generations. It promises a more and more complete understanding of the universe, as I indicated, and even creative power of chemistry over the structure of matter, the materials which are around us, the transformation of the non-living, but also of the living world, and progressively getting better and better control over disease, over aging, even over the evolution of the human species. Evolution has produced us, but now we are even able to act on evolution. And at some stage, I'm pretty sure we'll do that. Also trying to understand consciousness. How is it possible that one becomes conscious to be able to think on yourself and the origin of thinking? So, as you know, science has provided knowledge, and knowledge has then been transformed into technology, means of action. Science and its implementation through technology have also transformed society very much. You know that in the present age of information and telecommunications and so on, our life will change enormously. It has already changed. The way we operate has changed. We will be much closer together, even if we are long distances apart in terms of space. We will be able to get together through these novel technologies. Biological sciences are providing very new ways and new perspectives for understanding the living world. This is on one hand important for understanding, but it is also important for healthcare, food production, environmental control, and this will have very important impact on our own life. Economic and social problems also need science, need progress in science, and there's a challenge there. On one hand, an intellectual challenge, on the other one, a technical one.